Okay guys, so we're going to continue with the third example from this section, which should be 5-2. Notice that we have, so let me read what we have. It's simplifying a product. Where do I get the word product? Because we're multiplying two different radicals. We're multiplying two radicals. Notice that they do have the same index, which when you don't see it, we know that it's an imaginary 2. So we know that there's a 2 here and a 2 here as an index. So because they have the same index, we said earlier that we can combine them inside the same radical symbol, and I hope your symbols look a little bit straighter than mine. So 72 times 10. So let me actually do something. Let me go ahead and be more explicit. So because we're multiplying, remember we can also multiply inside. Let me extend this a little bit more. X to the third. And we're only allowed to do that because the indices are the same. We have the same index here as we do here. Okay, so we combine them under the same index and we multiply them. What do we get? We're going to get square root of 72 times 10, 720, x cubed times x to the first is going to be x to the fourth power, y to the second power times y to the third power is going to be y to the fifth power, because we have 2 plus 3. I'm so sorry guys. Y to the second times y to the third is y to the fifth power. So how do we reduce this now that we have it like this? Again, I'm going to use the trick of the number tree for 720. So I'm going to write 720 since I know that 720 ends in a 0. I know that it's divisible by a 5. Any number that ends in 0 and 5 is divisible by 5. So I know for a fact that 720 is going to have 5 as a prime number. When I divide that out, I realize that it's 5 times 144, and I say, wait, but 144 gives me a square because I have 12 and 12, so that means that 720 can be rewritten as 5 times 12 squared. And why am I interested in this squared? Because it's going to match this index, and it will eventually allow me to cancel it out. So using this index, I can say that I have 5 times 12 squared. I can rewrite that 4, remember, as a x squared squared. And what I'm going to do in this case is use the same thing with the y squared squared. That's going to give me 4y, but I have 5, so I'm going to multiply it times an extra y. So now let's see which one of these will actually cancel out. Since this 5 does not have an exponent of 2, it actually has an exponent of 1. It's going to stay inside. We'll move on to the next one. Let's take a look at this 12. What's the exponent here? 2. So we cancel it out with this, and it's allowed outside. What about this guy? It has an exponent of 2 here, so it cancels out again with the index. So the x squared comes outside. Remember, this square is different from the one that we canceled out. Same thing with the y. I'm going to have this exponent cancel out with the index, and this one comes outside with the variable, so it's y squared. And because this y has an exponent of 1, it's not going to meet the quota, so it's going to stay inside. So let's take a look at who actually stayed inside. This 12 came out, this x squared came out, this y squared came out, so inside we have 5 to the first power and y to the first power. So that's actually my simplified answer. Okay guys, so let's continue. Taking a look at some examples. In this case we're going to divide rational expressions, and to do that again we're going to require that the index in the numerator is the same as the index in the denominator, which they are. In this case it's 2 and 2 again. And since that's the case, a similar thing is going to happen as we saw before. We're going to combine this division of roots into one inside of one root. So we're going to have, instead of having two separate ones, we're going to bring this division inside, and we're going to have 18 x to the fifth divided by 2x cubed. Now keep in mind, last week we talked about what we did when we had something like this. There's a numerical part and there's an algebraic part. What do we do with the numbers? It's what we always do. What's 18 divided by 2? And the answer is 9. We also talked about what we do when we have equal bases. When we divide them, we talked about what to do with them, and the correct answer is we subtract them. Since x and x are equal bases, I'm going to subtract the exponents, and I'm going to get something like this. 5 minus 3 is going to yield 2, so 9. We now have 9x squared inside. And the next question to ask yourselves is, how can I rewrite this so that it has an exponent of 2? The answer in this case is very simple. We have 3 squared times an x squared, and because the exponent and the index are the same, we can remove these 3, and the same thing with the x. Remember, we cancel out. It's kind of like the fee you pay to come out, and you no longer have it outside. So that's my final answer. First, we want to check that this radical has the same index as this radical, which they do. The index here is a 3, the index here is a 3, so we can combine them on one big radical. We're going to bring the division here, so we're going to have 162 y to the fifth divided by a 3y squared. Now the process is going to be very similar. 162 divided by 3 is going to be 51. I always forget to add these. The cubic root of 162 divided by 3, remember the numerical part, which is divided. If you have a calculator handy, wait, that's not right. 54 is the correct answer, not 51. And again, we're going to repeat the process. 5 divided by 2. Y to the fifth divided by y squared is actually y to the 5 minus 2, because again, equal bases being divided, we subtract the exponents, and over here we get 54 y to the third power. And how can we group this? Earlier we talked about the 54. Remember that the 54 is 2 times 3 cubed. So I can actually go ahead and do this 2 times 3 cubed times y cubed. And again, we see who has enough to pay the fee. This index cancels out with this, I'm sorry, this exponent cancels out with this index. This exponent cancels out with this index. So outside we're going to have 3y times square root of 2 inside. And the reason why the square root of 2 stays inside is because it did not reach the quota, which was a 3. It stayed with an exponent of 1, so this is my final and simplified answer.